Have you ever pondered the question, why is electrical conduction so crucial to the heart's functionality? Well, it's a fascinating topic that weaves together the intricate design and operation of the human heart. The heart, an essential organ in the body, relies heavily on its electrical conduction system for effective functioning. This system is responsible for the heart's rhythmic contractions and relaxations, which pump blood throughout the body. It's a precise and well-coordinated process, where even the slightest disruption could lead to serious complications. In the heart's electrical conduction system, the journey begins at the sinus node, also known as the heart's natural pacemaker. This tiny cluster of cells, located in the right atrium, fires an electrical impulse that initiates each heartbeat. This impulse triggers the first stage of the cardiac cycle, the depolarization of the atria, which is represented by the P wave on an electrocardiogram, or ECG. After the atria contract and push blood into the ventricles, the electrical impulse arrives at the atrioventricular node, or AV node. This is a critical juncture in the conduction pathway, acting like a gate that slows down the electrical signal before it proceeds to the ventricles. This delay, depicted as the PR segment on the ECG, ensures that the atria empty completely before ventricular contraction begins. The next stage of the journey takes us to the ventricles, the heart's primary pumping chambers. The electrical impulse travels down the bundle of His and into the Purkinje fibers, causing the ventricles to contract. This process, known as ventricular depolarization, is represented by the QRS complex on the ECG. As the ventricles start to recover from the contraction, a process known as repolarization begins. It is during this phase that the ST segment is evident on the ECG. This segment indicates the initiation of ventricular repolarization, where the ventricles start to reset electrically in preparation for the next heartbeat. The final stage of the cardiac cycle is the completion of ventricular repolarization, represented by the T wave on the ECG. At this point, the heart is ready to start the cycle again, waiting for the next impulse from the sinus node. To sum up, the heart's electrical conduction system is a marvel of biological engineering. It begins with an electrical impulse from the sinus node, travels through the atria to the AV node, then down to the ventricles via the bundle of His and Purkinje fibers. Each phase of this process is represented on the ECG, a tool that enables clinicians to diagnose various cardiac conditions. It's a complex but essential system, ensuring that every heartbeat is well-timed and effective in pumping blood throughout our bodies.